Today we're going to we're going to talk about failure, particularly failure in the cloud. There's a classic quote from Leslie Lamport, which says that a distributed system, i.e. a cloud system, is one in which the failure of a computer you didn't even know existed can make your own computer unusable. And so let's talk about types of failures and then some phenomenon that exist because of these failures. If you do a search on cloud outages last year, what you'll get is a list. Some are more serious than others, some last longer than others, but they all occur, and if you look down there, it's all of the vendors. There's nobody that's special in terms of not having failures. And sometimes just a part of it fails. So there's some data about Google data centers in a year. So you have overheating, you have rack failures, you have racks going wonky. That's a technical term. The most interesting one here is the dead horse. So the story is that a farmer was burying a dead horse and with a backhoe and dug through a power circuit for a Google data center, and so the data center went offline until they repaired the power. Amazon doesn't have quite such detailed statistics, but it's similar. If you have a standard data center which has somewhere around 64,000 servers, and each server has 2 disks, then 5 servers and 17 disks more or less will fail every day. And so these failures, if you have 64,000 computers and 5 of them fail, what are the chances that your application is running on one of these, and what is the impact of it? And that's where Leslie Lamport's quote comes in. So let me digress just a little bit into probability. So a probability distribution gives you the probability that any given reading will have a particular value. And normally distributed probability distributions are quite common in nature. And what that means is that most values will cluster around the mean, and as you go out toward the edges you get a smaller number of values that are likely. And in a normal distribution the mean is equal to the median. Okay, the long tail distribution is different. So in a long tail distribution there are some values that are very, very far out. They're far from the mean. And these values are sufficient to influence the mean, so you can tell if you might have a long tail phenomenon by comparing the mean and the median. And these are dramatically different in a long tail distribution. So how does that apply? Well, let's put this back into the cloud. Some activities will take a long time to complete and exhibit a long tail. Here's some data that comes from making 1,000 AWS create instance calls. Somewhere around 5% of those calls were the long tail. So what do you do to protect yourself against the long tail? Well, there are 3 different techniques. One is you have to recognize that a failure has occurred and you can recover from the failure, or you can mask failure. So recognizing failure in a distributed system is a matter of messages. The only communication between distinct computers is through messages. So a request to another machine goes unanswered. Okay, it may indicate a failure, and the failure must be recognized by the requester. You also can have cooperative types of checks. You can have a health check, and one machine sends a monitor your machine sends a message to a monitor saying I'm alive, and so you know it's alive. Or you can do what's called a ping echo, which is, are you alive? And the answer is yes, I am alive. So what do you do if you think you have a failure? So one option is you can retry it. Okay, maybe the failure has nothing to do with the service you're trying to reach. It's something in the network between you, and if you try it again, maybe it'll take a different path, or maybe the error was sporadic. And so retrying is actually built into the protocols that the browsers use. So a browser will send a request, If it doesn't get a response in a certain amount of time, it'll try it again. And, then there's okay, after a while the browser says, okay, this isn't going to work and I need to do something else. So it can report an error message or it can try an alternative. Another thing you can do is create another instance of a failed service. If the service has failed, then create another, and it's stateless, you can create another instance. There's something called graceful degradation, which is, okay, the service I want doesn't work. I can't get exactly what I want, but let me try some things that will give me approximately what I want. That's called graceful degradation. There's a pattern called a circuit breaker, and that will prevent trying to use the service again if you know that it's failed. And Netflix has an open source library. One of the entries in their open source library is called Historics, and that has a number of useful functions along these lines. Or you can mask failure. What does it mean to mask failure? It means that you know that failure is likely, and so you do things to prevent the failure from affecting you. You can do what's called a hedge request. And let's go back to the launch example. You want to launch 10 instances, you issue 11 requests. And then once 10 have been instantiated, you cancel the 11th request. You could do the same thing where you issue 10 requests, and when 8 requests have completed, you would issue 2 more, and then you would cancel the last 2 to respond. And some experiments show that these techniques reduces the time of the longest, again, of the 1,000 launch instances from 200 seconds to 51 seconds. So to summarize, the cloud's on demand, but portions may fail. And consumers of the cloud must be aware that failure can occur anytime, and this includes during the operation of an application or a DevOps tool.